Hello, sir. I am Mir Kataria, and today me and my group are going to present a project on dog breed classification. So, my group member includes Aviraj Mane, Om Kinge, and Saurabh Pardi. The project is for computer vision, and we are from Pimpri Chinchwad College of Engineering from computer branch. So, in this project, uh, we have imported some Python libraries like OS, Random, NumPy, Warnings, TensorFlow, Keras, Pandas, sklearn, and Matplotlib. Uh, we have begun by setting a randomization seed in a Python environment for the purpose of replicability. By setting a randomization seed, it ensures that any random process or functions that rely on randomness produce the same result every time program is executed. So first, we have set the Python hash seed, and then we have set uh, random seed. Then we have set TensorFlow. We have suppressed warnings, and then we have set TensorFlow random seed. Uh, Further will be continued by Viraj.
Yeah, thanks, Mir. So now we will take a look at the data set which we have considered. So here first we have imported the data set of dog data consisting of the various features such as age, height, weight, and breed. Then we have taken the main feature to be predicted, that is breed. Then encoded the breed column into one hot vectors. Thus, process is equal to false argument ensures that the output is a dense matrix. And then we have divided the half data set as a training data and other half as a testing data. We have displayed the first 10 records here. So after that, then we have deployed some functions related to training and evaluating neural networks using keras and matplotlib. So train network function trains a neural network with specified architecture and training parameters. Plot accuracy function plots the training and testing accuracy on a line graph to compare how they evolve during the training. Bar accuracy function plots the training and testing accuracy as bar charts to compare their performance. These functions are designed to train neural networks, track their training progress, and visualize the accuracy results. Now I will like to hand over to Saurabh.
Thank you, Aviraj. I am going to explain the activation function. So the program here is a loop that evaluates the performance of neural network with a single hidden layer while varying the numbers of neurons in the hidden layer from 1 to 10. Within each iteration, it trains a neural network with a specified architecture and the current number of neurons in the hidden layer. It appends the final training accuracy and testing accuracy of the current model to the train and test array. After each model evaluation, it plots the training and testing accuracy using the plot function. Then we have programmed to evaluate the impact of different activation functions on the performance of neural network. It compares the performance of neural network with the fixed architecture, input layer with 3 units, one hidden layer with 4 units, and another hidden layer with 2 units. While varying the activation functions, it then plots and compares the training and testing accuracy of each activation function. Activation function plays a crucial role in a neural network by introducing a non-linearity. They determine whether a neuron should be activated or not. Explanation of different activation function using code is we have used exponential linear unit. It helps to mitigate the vanishing gradient problem and can produce negative values, which can be useful in certain situations. Then we have scaled exponential linear unit, similar to exponential linear unit, but it has some specific properties that can improve the network's performance. Then we have rectified linear unit, a widely used activation function that introduces non-linearity by zeroing out negative values. Then we have tanh, which produces values between -1 and 1, making it useful for bounded activation. We have sigmoid, which is a S-shaped curve that produce values between 0 and 1, often used in binary classification problem. Then we have soft sign, another smooth function that behaves similarly to 10h. Then we have linear, the identity function, meaning it passes the input as it is. So by comparing the performance of same neural network architecture with different activation functions, this code aims to determine which activation function work best for the specified task, as the choice of activation function can significantly impact on neural network's performance. So the further explanation will be given by Om.
Thank you, Saurabh. I will be explaining the optimizers. Optimizers are algorithms used during the training of neural networks to adjust the models for parameters in order to minimize the loss function and improve the model's performance. So the program here compares the impact of different optimization functions on the training and performance of a neural network. It basically iterates through a list of optimization functions and evaluates the network's performance using each one, and then plots and compares the training and testing accuracy of each optimizer. So explanation of some of the optimizers used in the code are so the first one is SGD. So the SGD is a stochastic gradient descent, a basic which is a basic optimizer that updates weights by taking small steps in the direction that minimizes the loss using a learning rate. So the second one is RMS prop, which is root mean square propagation, which is an adaptive learning rate optimizer that adjusts the learning rate for each parameter based on the magnitude of recent gradients. The third one is AdaGrad. AdaGrad is an adaptive gradient descent, which is an optimizer that adapts the learning rate individually for each parameter based on the historical gradient information. So the next one is ADA Delta, which is an extension of AdaGrad that uses a moving average of gradients to adaptively adjust the learning rate. Next one is ADAM, which is adaptive movement estimation, which is an optimizer that combines the benefits of both momentum and RMS prop, making it one of the most popular optimizers. And the last one is ADAMX, which is a variant of Adam that uses the L infinity norm for gradient scaling. And the last one is NADAM. It is a Nesterov Adam, a variant of Adam that includes Nesterov momentum. And by comparing the performance of the same network architecture with different optimizers, the code aims to determine which optimizer works best for the specific task, as the choice of optimizer can have a significant impact on training time and the final performance of the neural network. So at last, we had visualized the training progress and performance of our neural network over time. The accuracy curve shows how well the model is learning, while the training loss curve indicates how well the model is fitting. These visualizations can help to assess whether the model is converging and identify any overfitting or underfitting issues. Thank you.
Thank you.